Hello and welcome. In this video presentation, we are going to demonstrate how to create a decentralized application for blockchain peer-to-peer lending system using Ethereum blockchain. We will start from scratch and go up all the way to design, develop, test and implement this DApp. In the beginning, we will define requirements and related functional components. Then we will collect user stories and carve out technical requirements from them. Once the previous two exercises are done, we will shift our focus to defining tech stack architecture, which will elaborate what technologies we are going to employ to implement the project. Then we will decide which framework we are going to use. Then we will try to understand and create smart contract, which is nothing but blockchain implementation or a back end of DApp. After that, we will understand and implement the client side or the front end of the DApp. Once the development is done, we will write test cases and perform testing and modify the DApp if required. Then we will develop the application locally. Finally, we will see a live demonstration of how the DApp works. We will follow these guidelines while developing our project. Hello and welcome back. To keep our demonstration guided, we will refer this document to describe various stages of the development process. So let us start the presentation. This project is all about creating a blockchain peer-to-peer lending system, which will facilitate borrowing and lending of cryptocurrency like Ether onto blockchain. The outcome of this project provides a system where parties like borrowers and lenders can come together and transact using public blockchain network like Ethereum. To get more detail, let us look into the document. So we begin with the requirements, which are broadly categorized as functional requirements and technical requirements. To collect the requirements, we have employed agile user stories technique where we document the requirements from each role user describing their needs and the expectation from the system. So we can see the needs of borrowers. For example, they would like to add new mortgages documents to the blockchain. Similarly, the lender would like to verify the mortgage document before placing a loan proposal. Also, the borrower needs to be able to apply for a loan using their mortgage document. Likewise, the lender should be able to place a loan proposal against the loan request. Then the borrower should be able to select the loan proposal. Finally, the borrower should be able to repay the loan, which the lender should be able to get back with interest. So these user stories help collect the requirements and determine the acceptance criteria which will guide during the testing system. During the testing of the system. After the user stories have been documented, they help determine functional requirements. For example, in order to cater various needs expressed in the user stories, we need to design the system functionalities, means how the system would fulfill the requirements of each user role. So this table shows the functional component to support the functionalities as expected by each user role. For example, the landing page or home page of the DApp frontend will provide navigation to mortgages page where the borrower can add mortgage documents to blockchain, actually the hash value of the document. Similarly, navigation to borrower page will allow the borrower to place a loan request, accept a loan proposal and repay the loan with interest. Finally, navigation to lender page will allow the lender to place loan proposals with a specific loan amount and interest rate. To support the functionalities as described earlier in the functional requirements, we need to implement a DApp, a decentralized application, and following are the software requirements to develop the DApp. For instance, we need to create Solidity smart contract which contains the business logic and resides in the blockchain. Then we need to develop individual front-end or user interface pages like home page, mortgage page, etc. We have selected Ethereum public network with POW as consensus algorithm. Also, we will use MetaMask which contains private keys and address of the individual users. We will use React JavaScript library to create the front-end pages. In this basic DApp, we are not developing any centralized backend. to either provide APIs facility or data storage facility since they are not required at this moment. Now let us talk about its architecture. As we can see from the diagram, there are only two layers, presentation layer and the backend layer. The various users of the system can interact among themselves using the front-end application which talks to the blockchain where the actual business logic is saved. The user needs to access the homepage of the DApp and log into using MetaMask address and private keys. The Ethereum address has been designated as the login ID. Various participating service companies like those providing gateways and value-added services along with P2P lending platform can have a full node implemented, while the individual lenders and borrowers need not do so. They simply can have a light node to access the blockchain network. For the tech stack, we are using Ethereum blockchain as backend with Solidity programming language to write the business logic. Also, we are using MetaMask for the key management and login and React.js to develop the front end. This is the smart contract code written in the Solidity programming language. We can see that various subcomponents of the business logic have been codified in this contract. So we have written two contracts. One is mortgage and another is crowd bank. The mortgage is to add mortgage document to the blockchain, and CrowdBank is the contract which handles the actual borrowing and lending between two parties. Client-side implementation. We have created mainly three pages for the user interface. They are mortgages, borrower, and lender pages. Mortgage page. On this page, the borrower can add a document to blockchain and the lender can verify a mortgage document by owner or verify an owner by mortgage document. Borrower page. On borrower page, using this page, the borrower can apply for a loan, view loan proposal, accept and lock a loan proposal and repay the loan eventually. Lender page. Using this page, the lender can view the loan request, place a loan proposal and revoke a loan proposal. Writing the test scripts. We have written two test script programs. One is for mortgage.js and another is crowdbank.js. So we can see that the test script program written in JavaScript and executed via Truffle console. We can see that the test cases which verify the individual subcomponents of the Solidity program, contract program, and they are there to check and functionalities of the logic of the business logic. In blockchain projects, it is must that before we deploy the smart contract on Ethereum blockchain, we should test it using Truffle framework or any other framework. Because once a contract has been deployed to the Ethereum blockchain, we cannot modify it. So the testing is very crucial part, and later on while we have a code walkthrough, we will also run the test scripts to verify whether all the logics are working properly or not. Here is the detail about deployment. We'll see it later how we are going to deploy it, and we are going to execute all these steps as mentioned. As part of live demonstration, we will execute the following test cases while interacting with the DApp.